Hello and welcome to this video. In this video we are talking about the edit distance problem and how we can use map and reduce higher order functions in order to solve problems. The objective of edit distance function is to find the minimum number of substitution, insertion or deletion required to convert one string to another. For instance, the edit distance between these two strings are 4 because the first characters of these two strings are the same. We skip to the second character. The first T character we need to remove it from the first string, and then we need a substitution to convert T to C in another strings, and then the A and T characters are the same, therefore we don't do anything. At the end we need an insertion of T and a deletion of the G to convert first string into another. Another example is when we want to convert the word spam into a scramble. The edit distance is 5 in this case. The first two characters of these two strings are S, so they are equal. We go to the second character. We need to convert P with C to get the scam word, and then we need an insertion of R to get the scram, and then we need 3 insertion to get a scramble. If we want to write down this function in a recursive way, we need to think about the base cases. We can consider 3 base cases. When one of the strings are empty, so for instance if S1 is empty, we just need to insert all the characters into this 2. So the edit distance is gonna be len of S2. And in similar case, when S2 is empty, we all need all the insertion or deletion of S1, and therefore the result is going to be len of S1. And if the first two characters, the first character of these two strings are similar, we can reduce our problem size by 1 from each these two strings. But when the characters of these two strings are not the same, we are facing with 3 options. The first option is to substitute these two first characters together. Another option is to insert one character from S1 into this 2. And the third one is to delete one element from S1. At the end, we need to take the minimum of these 3 options, and this is gonna be our edit distance. So in the case that we are considering substitution, when we are substitute 2 characters, the cost of substitution in this case is 1, and we need to add it to the edit distance of remaining of S1 and S2. For insertion, because we are inserting into the S2, therefore we can start from index of S2 to the end of and go to the end of this using a slicing operator and feeding it into edit distance. For deletions, we are deleting from S1 Therefore, we can move the index of S1 by 1 or reduce the problem size of S1 by 1. So let's take a look at execution of this code in our Spyder. You can see this code in here, and if I run this code, it gives me the edit distance between a spam and a scramble, which is 5, and our recursive code works properly. For the preparation of Monday's session, I want you guys to take a look at the edit distance code and change it with considering different costs for substitution, insertion, and deletion. So in our code, we are considering that all of these three options have the same cost, and the cost is 1. But consider that the cost of substitution is 4, cost of insertion is 2, and cost of deletion is 1. How our implementation is different from the weighted distance function. So please implement your function in a weighted distance .py file and use the following test case. So with this change, the weighted edit distance of a spam and a scramble is 7 instead of 5. We've seen how to use the higher order map function, which applies one function to all the elements of the list and gives us another list. We have another function named reduce, which doing a similar job to map, but instead of giving us a list of elements, it returns only a single value. And this function initially calls the first two elements from the sequence, and it returns the result. And if the sequence have more than 2 elements, it's gonna repeat this process recursively. As the name of this function reduce suggests, the function that we are applying needs to get 2 inputs and returns 1. Please pay attention that in Python 3, in order to use reduce function, you need to import functools module using the keyword from, and import you can specify which function do you want to import from functools. In this case, we are importing reduce function. Then you are seeing the function definition of add and multiplication, and with applying reduce using the add function to the 1, 2, 3, and 4 list, the result you will get is 10, which is the summation of all these numbers. If we apply the multiplication function using the reduce, we're gonna get 24, which is 4 factorial. So this shows that we can implement the factorial function using reduce. And also we can apply both same and reduce to a sequence to at first apply one function to all the elements, and then we reduce it to one value. In this example, you can see a code that gets 2 functions. One is a map function and another one is a reduce, and it's gonna apply at first map and then reduce functions to these lists. In this example, we called MapReduce with triple and add functions on these lists. So this makes it all these elements to be tripled at first, and then we're gonna add all of these elements together. This shows the power of map and reduce function. I hope you guys enjoyed this video. Thank you so much for your time.